Okay. So hello bachcho, how are you? Good morning everyone. I hope your preparation is going very well. So in this lecture I am going to discuss with you logarithmic inequalities. So before discussing logarithmic inequalities, I will discuss with you some observation. Based on that observation, I will write some conclusion. And after writing some conclusion, then I will solve some question based on logarithmic inequalities. Suppose if I am writing here y is equal to log x base a. So when this expression will be defined? So if I am writing y is equal to log x base a, so this x must be greater than 0, base must be greater than 0 and base should not be equal to 1. So these three conditions must satisfy. If I am writing y is equal to log x base a, so x must be greater than 0, base must be greater than 0 and base should not be equal to 1. So these things I have already discussed in previous classes, basics of log and logarithmic equation chapter. Yes or no? Yes, okay. So now next I will discuss here two observation, and based on these two observation I will write some conclusion. So what is my observation number first? So I am writing here observation number first. So if I am writing here log 1 base 2, log 2 base 2 and log 4 base 2. So what will be output here? So log 1 base 2 output is 0. Log 2 base 2 output is 1 and log 4 base 2 output is 2. So what is important thing here? So this time I taken base greater than 1. Base is greater than 1, and if I am increasing this number, so if I am increasing this number, output is also increasing. Output is also increasing. So here base is greater than 1. So output is increasing. Output is increasing. So now observation number 2. So now in observation number 2, what I will do? I will take same expression, but I will write base less than 1 but greater than 0. So I am writing here log 1 base 1 by 2, log 2 base 1 by 2, log 4 base 1 by 2. So what will be output here? So output is here 0. Here output is minus 1 and here output is, this is 1 by 2. So output is minus 2. So what is important point here? Same expression I had written, but this time I taken base greater than 0 but less than 1. So output is here decreasing if I am increasing this number. So if base is less than 1, if I am increasing this number, output is decreasing. Output is decreasing. So if base greater than 0 but less than 1, output is decreasing. Output is decreasing. So this two observation is very, very important. So this two observation is very, very important points here. So you have to learn from this observation. So next I am writing here one conclusion, small conclusion. So now tell me here. So if I am writing x greater than y and base a greater than 1. Sorry, base a greater than 1. Base a greater than 1. So what will be sign of inequality here? So now tell me everyone. So if base is greater than 1 and those number which is greater will give me greater output, no? Yes or no? So here greater log x base a greater than log y base a. Yes or no? Yes. So now next conclusion again. Now tell me again, if x greater than y but this time base is greater than 0 but less than 1. So now I am writing here log x base a, log y base a. So which kind of inequality will come here? So here this time those number which is greater will give me lesser value, na, if base is less than 1. So here this kind of inequality will come here. So this is the conclusion I want to teach you from these two observation. Yes or no? So can I erase this? Next I will draw the graph of log function. So I am erasing this. So can I draw here graph of log function here? Suppose if I am writing here y is equal to log x. Okay, next page I will write here. I'm erasing this. Okay, I'm erasing this. So next I will draw the graph of log function. So if base is greater than 1, so if base is greater than 1, log function is increasing function. And if base is less than 1, log function is decreasing function. So while solving logarithmic inequality, always check base. These things I want to teach you from these two observations. So while solving logarithmic inequality, you must have to check base always. Yes or no? So if base is greater than 1, so log is increasing function. So sign of inequality will not change. Okay, let me erase this. Later I will write. Okay, let me erase this clearly. So if base is greater than 1, so suppose if I am writing one expression again here. So if I am writing y is equal to log x, base a. This time I am writing base greater than 1. So this x must be greater than 0. Clear? So what will be graph of log function? So when base is greater than 1, so this is the graph of log function. So this value is 1. So this is x here. This is y is equal to log x base a. So here base greater than 1. Now tell me if base is less than 1. If base is less than 1. So, so if y is equal to log x base a. So this time I am writing base greater than 0 but less than 1. So what will be graph of log function? So again I am drawing here graph of log function. So y is equal to log x base a. So this time graph will be decreasing function. So graph will be like this. So this is the graph of y is equal to log x base a, but here base greater than 0 but less than 1. So these two things you must have to remember before solving logarithmic inequality. So can I erase this graph? Next I will write. So now tell me, so if you are solving logarithmic inequality, you must have to check base always. Yes or no? So if base is greater than 1, so one more conclusion I am writing here. So while solving logarithmic inequalities, always check base. So I am writing here if base is greater than 1, so sign of inequality does not change. First, if base is greater than 1, sign of inequality does not change. Sign of inequality does not change. And if base greater than 0 but less than 1, so sign of inequality will change. So sign of inequality will change. So in next page we will solve some question based on logarithmic inequality. So this is the conclusion I want to teach you with the help of these two observations. So these two conclusion I had written. So while solving logarithmic inequality, always check base. If base is greater than 1, sign of inequality does not change. If base is less than 1, sign of inequality change. So next I will discuss 2-3 questions. That questions already asked in JEE mains and JEE mains previous year questions. That question I will discuss. So can I erase this again here? So any confusion up to here? Okay, no confusion. So I am going to erase this. Next I will write here question. So now I will discuss with you some questions of logarithmic inequalities. Okay, so first question I am writing here. So if I am writing here log x plus 2 base 0.3 greater than log x plus 1 base is 0.09. So now here asking here find value of x. Find value of x here. So find value of x. So how to solve this logarithmic inequality? So before solving logarithmic inequality, I told you, so always check base. So here base is 0.3 and here 0.09 given. So you have to make same base both side before solving logarithmic inequality. So I have already discussed with you properties of log. So here 0.09 given, here 0.3 given. So first I have to make here same base both side. So here this 0.09 is nothing but 0.3 whole square. So I will use here one property of log. So if I am writing here log x base a raised to the power n. So this becomes 1 by n log x base a. And this 1 by n again will come this side here. So log x raised to the power 1 by n base a. So base n. So can I write directly here? So I am writing here. So log x plus 2 base 0.3 greater than log x plus 1 here 0.3 whole square. So this 2 will come this side now, and after this again this side. So I am writing directly here. So here, so log x plus 2 0.3 greater than log x plus 1 raised to the power 1 by 2 0.3. So now both side base is same. So can I remove log? So before removing log, always check base. So here base is less than 1. So sign of inequality will change here. So sign of inequality will change. So x plus 2 less than x plus 1 raised to the power 1 by 2. So you already know how to solve this kind of expression in basic math already completed. So now tell me, so when this expression log will define? So log will define when this x plus 2 positive. So this x plus 2 must be greater than 0 and here x plus 1. So this x plus 1 also must be greater than 0 now. So this x plus 1 must be greater than 0. So this x plus 2 and x plus 1 is positive. So can I do a squaring both side? So I can do a squaring both side. So after squaring I am writing here x square plus 2ab plus 4x plus 4 less than x plus 1. So here x square plus 3x plus 3 less than 0. And here x greater than minus 2 and x greater than minus 1. So what will be answer here? So from here x must be greater than minus 1. And here x square plus 3x plus 3 less than 0. So this is quadratic. Is this factorizable? So this is not factorizable. So check here D. So what is value of D here? So value of A is here 1. What is D here? So D less than 0. B square minus 4AC. 3 square minus 4 into 3. So D less than 0. So this quadratic equation is greater than 0. But here asking less than 0. So what is value of x? So no such value of x that satisfy this condition. So x is equal to 5 here. And x greater than minus 1. So what will be my final answer? So final answer will be x belongs to 5 here. No such value of x that satisfy this condition. Yes or no? So no such value of x that will satisfy this condition. So this is the simple question I had taken for solving, for understanding this logarithmic inequality, that two rules. But next I will discuss two questions, very, very important questions. So this question is very basic questions I had taken. But next I will discuss two questions, important questions. So I am going to erase. So I am erasing this. Next I will write important question. And that question is very, very important. And that type of questions JEE asking every year. Okay. So now, so while solving logarithmic inequality, you must have to check always base. Base is playing very, very important role here. So now I am writing here next question. So one question I am writing here. So here log base is 0.5. Base is 0.5. So here log base is 8. Here x square minus 2x divided by x minus 3. X minus 3 less than 0. So now find value of x here. So find value of x. Find value of x. So how to find value of x here? So now tell me how to find value of x here. So now first try to solve by yourself. After solving by yourself, first try to solve by yourself. First pause the video and try to solve by yourself. After that you can match your answer. Okay. Okay. So can I solve now? So now I am going to solve this question. So now tell me here. So log point base is 0.5, log something given. So when this, first I have to define this expression. Yes or no? So before solving log, so you must have to define first log function. So now log something, if log something written, this something must be greater than 0. So I am writing here. So log base 8, x square minus 2x divided by x minus 3 must be greater than 0. I am writing end here. So for defining this expression again, this x square minus 2x divided by x minus 3 must be greater than 0. Must be greater than 0. Yes or no? So now solve this. And now tell me here. So first solve this here. So x square minus 2x divided by x minus 3. Here base is greater than 1. Base is 8. So here greater than 1. So sign of inequality will not change here. So this is greater than 1 and x square minus 2x divided by x minus 3 greater than 0. So now tell me here. So x square minus 2x divided by x minus 3 greater than 1 and x square minus 2x divided by x minus 3 greater than 0. So which value I have to consider? Here greater than 0, here greater than 1. I have to take common value now. So I can write from this here. So x square minus 2x divided by x minus 3 greater than 1. But this is not my final answer. So I have to solve this side also now. So here I have defined only this expression log. But so now again remove here log. So if I will remove this log, so here base is 0.5. Base is less than, here base is less than 1. So sign of inequality will change here. So again here log x square minus 2x divided by x minus 3 greater than 1. Greater than 1. And here base is 8 given. Base is 8 given now. So now again remove this log. So if you remove this log, here again check base. This time base is 8. So here, so x square minus 2x divided by x minus 3 greater than 8. So now tell me what is common value? Common. So here end you have to write. So what is common here? So x square minus 2x divided by x minus 3 greater than 1 and x square minus 2x divided by x minus 3 greater than 8. So can I write here? So x square minus 2x divided by x minus 3 greater than 8. So this is common among these three value now. Yes or no? So now you have to solve only one expression. No need to solve three expression here. So here I had defined this log. So whatever here written, this must be greater than 0. And see here, x square minus 2x, this also must be greater than 0 now. Yes or no? And solve this two expression. So from here I am getting x square minus 2x divided by x minus 3 greater than 1. And now solve here. So here base is less than 1. So while removing log, so now sign of inequality change na. So here sign of inequality less than given. So here greater than, and again remove. So again base is greater than 1. So remove this log. Here sign of inequality will not change. Now take common. So what is common? X square minus 2x divided by x minus 3 is greater than 8. This is common here. So now solve here, you will get answer. So no need to take common. Only solve this expression, you will get answer. So now take 8 this side. So x square minus 2x. So this x minus 3 is LCM. So here, so minus 8 into x minus 3 greater than 0. So what is this? X square minus 2x minus 8x. So x square minus 10x minus plus 24 divided by x minus 3 greater than 0. Now factorize this expression. So can I write x minus 6, x minus 4? So this is x minus 6 into x minus 4 divided by x minus 3. This is greater than 0. So what will be value of x? So draw number line here. So this is 3, this is 4, this is 6. So everywhere put bubble here. So plus minus plus minus. So I need greater than 0. So from here to here. So what will be my answer? So x belongs to 0 to 3 union 6 to plus infinite. So union 6 to plus infinite. So this is my final answer. So this is my final answer. Any confusion up to here? If you have a confusion, you can ask question. I will revise. If you have any confusion, you can ask. I will revise once again. So now this question is very, very easy question. So this kind of questions IITJEE asking every year. So next I will discuss here variable base. This time I had taken here constant base. In previous question, that question was very basic question. In this question I taken constant base less than 1. But next question again I will discuss with variable base. So can I erase this? One more question I will discuss after this. So I am going to erase this. Okay. So now I am erasing this. So logarithmic inequality is very, very important chapter. Log is also very, very important chapter. Direct log based question not asking, but in some other chapters log is used. And nowadays so now I am taking next question here. So here next question is again log base is x plus 3. Here x square minus x less than 1. Now tell me again how to solve this question. This question is again very simple question. So before solving this logarithmic inequality, first you have to define this expression. So for defining this expression, you have to write that 3 condition. So here, so for defining this x square minus x must be greater than 0 and x plus 3 must be greater than 0 and x plus 3 should not is equal to 1. So here I am taking x common. So here x minus 1 greater than 0 and x greater than minus 3 and here x should not is equal to minus 2. So here x into x minus 1. X into x minus 1. So here this is 0, this is plus 1, plus minus plus. So this side x greater than minus 3. So x greater than minus 3 I am writing here. So this side and x should not is equal to 2. So what will be my domain here? X belongs to minus 3 to 0 union 1 to plus infinite minus 2. So before solving this kind of question, you must have to define first. So now I have defined here. Here base is also variable. So here base is also variable. Clear now? So any confusion? So now I have to take here 2 case. Here base is also variable. So before this question I had taken constant base. But here base is also variable. So now I will take case first. So in case first I am taking base greater than 1. So x plus 3 greater than 1. So x must be greater than minus 2. So now if base is greater than 1, while solving logarithmic inequality, sign of inequality does not change. Sign of inequality does not change. So here, so x square minus x less than 1. X square minus x less than 1. Sorry. So here x plus 3. So now take this side. So x square minus 2x minus 3 less than 0. So here x square So minus 3x plus x minus 3 less than 0. So x common. So x minus 3 here plus 1. So x minus 3 less than 0. So here x plus 1 into x minus 3 less than 0. So here this is minus 1, this is plus 3. So plus minus plus. So I need less than 0. I need less than 0 now. But here x must be greater than minus 2. So minus 2 is here. So x must be greater than minus 2. So from where to where common? So from here I am getting value of x is minus 1 to 3. But this is not my final answer. Final answer I will write later. So this is case first. So from case first I am getting value of x is minus 1 to 3. So now case 2 again. So this is case 2. I will take base less than 1 but greater than 0. So base greater than 0. So greater than x plus 3 but less than 1. So this is minus 3. X must be 1 minus 3. So x must be between minus 3 to minus 2. Minus 3 to minus 2. So now, so base is less than 1. So sign of inequality will change now. So now sign of inequality will change here. So x square minus x greater than x plus 3. So same expression I am writing here. So I am writing x plus 1 into x minus 3 but greater than 0. Greater than 0. So from here, so this is minus 1, this is 3, plus minus plus. So this side, but this side no common value na. So from here, value of x is minus 3 to minus 2. So minus 3 to minus 2, this is common value. So from case 2, I am getting value of x is minus 3 to minus 2. And from case I am getting value of x is minus 1 to 3. So is this my final answer? Is this my final answer? No. So now I have to take intersection from domain. Domain already calculated here na. So now from here I have to take common value. Common value of x from these two condition. So this is my first, this is second, and this is third. So in this, from these three equation you have to write common value of x. So now I am writing here common value of x. So my domain is minus 3 to 0. So this is minus 3, this is 0. So minus 3 to 0. Union 1 to infinite. So 1 to infinite this side. And minus 2. So I have to subtract this minus 2. So I am subtracting minus 2 here. Now from case 1, I am getting value of x is minus 1 to 3. So minus 1. So minus 1 will be here. So minus 1 to 3. So from here, so here common things. Common na? So from here to here common. And from here minus 3 to minus 2. So here minus 3 to minus 2. So what will be my final answer? So final answer is x belongs to minus 3 to minus 2 union 1 to 3. So this will be my final answer. So this will be my final answer. So in this question I had taken base also variable. So base also variable. Before this question I had taken base constant. So three types of question now I have solved here, and one question I am giving you homework question. So can I give you homework question? Okay. So write one homework question. Okay. So thank you. Thank you for watching this video. Next video I will discuss some important questions again. Okay. Thank you.